Hey everybody, I am Flo Bachinger and I'm a developer advocate at Cisco. And today I would like to go through and talk to you about my MLOps workflow with Kubeflow. So this is my GitHub repository where I put everything there, and this is basically the whole pipeline there, which I want to go through with you. So you can deploy Kubeflow on any Kubernetes cluster of your choice. I will show you in a bit like what kinds are supported, but usually it should be fine. Then I used Jupyter Notebook instance in order to create the machine learning code and so on. Then I created like a Kubeflow pipelines components. So basically the goal is getting the data, putting everything interestingly into the Kubeflow pipeline components there. And then finally, we will serve the final model, the pre-trained model with Kserve, with a Kserve instance. And finally, we can do the recognize, or the program is basically recognizing the digits here. Yeah, all right. So I think let's go. So like along the way, I will show you like min.io, like what kind of data storage and model I used. But yeah, basically it should be a good start for you, to get started with Kubeflow, get started with the pipelines with notebooks and so on. And we have a simple demo. So sorry, like I wasn't talking about it. So it's like a simple digit recognizing the digits. Because I think you know it, like this is the classic digitized recognizing the digits image data set. So we have this data sets. It's like the Hello World 101 data set where you have like all these digits there. And then we will basically say, hey, okay, what's a digit like? Like our Kserve model inference server will basically, you can put an image in there or like send the image to the server, and back comes the probability and the accuracy basically on the probability, like what kind of digit it is. Yeah, I think let's get started. So like I have put here like all the Kubernetes cluster, like all the information there. So first of all, like if you go to Kubeflow, like Kubeflow website, you can see like all the information there. And then again, here's the information. So getting started is like installing Kubeflow. So these are the maintainers there, or like these are the distributions. Or you can, like what I did, is basically like install the Kubeflow manifests manually there. Yeah, all right. Like with that being said, you should see then like with kube control all these specific pods which are running up there. So let me just go here, open a new tab, and you can see here like all the namespaces which are running. Yeah, like these kinds of things. It should be like completely normal for you to see. Let me just close this. All right, then let's move forward and then access the Kubeflow central dashboard. So like if everything is running, as you can see here, like everything is in good shape and ready and running, then you like, depending on your setting, of course, but what I did is basically you can do a kube control port forward, like it's a hack basically, like that you can access the dashboard. So again, I open my iTerm here, I do the port forward, and there you see. So right now, if I go now to my local host and then 8080, you should see, hey, Kubeflow. So I was logged in already. So basically I've logged out, like you can see the login, and then it's going in again. And you can see here, like this is the Kubeflow dashboard. Right now, just for you to know, like this is Kubeflow version 1.5.1, I think, like 1.5 for sure. And here you can see like all this is like what they put in there basically. Cool. Then let's get further. Like right now it's like there is let's go to number 3. So is about set up the Jupyter notebooks. So as you know, so maybe like Jupyter notebooks are there, and actually I can show you in a bit, like to basically interact. You can code Python in there, you can have visualized Python and graphs there, and you can work together with your team. The thing with Kubeflow, however, is the following, that you need to allow, like, because it's a security measurement, so like Kubeflow is using DEX authentication, and they have, of course, some security measurements there. you need to allow access to Kubeflow pipelines from Jupyter Notebook. So what does it mean? It's like Jupyter pipelines, like this is a component. And in order to gain access to this component from the Jupyter Notebook instance, you need to basically say, hey, I would like to allow access. This is all written as well in the documentation. But what you need to do is simple run this command and basically apply this YAML file. And this YAML file you can see actually here in the GitHub repository. Oh no, this is the wrong link. This is in the Kubeflow configs and then access Kubeflow pipelines there. So basically you should just write in there here, this is your namespace. And this is usually like if you are following the same, like you do it manually, install it, you can go to manage contributors and you can see here, this is basically the namespace kubeflow -user -example.com. This is the namespace there. Yeah, so like if you did this, so like you just need to edit this one here. And then this is basically it. So here we basically say, hey, you are allowed, or like this instance is allowed from this name is allowed to access the machine learning pipelines there. So I did this already, but basically I can apply it again. Let me just go back here to the number 3 here. So you can see here like Kubeflow Notebook instance. So when I go here to documents, this is my GitHub stuff and so on. So these are the examples. So these are the Kubeflow configs there. And then when you just click there, then this would be the same. You just edit there. Let's go like this. You just type in here, like I said, like Kubeflow user example.com, and then like I won't do this now, but like you can then just execute this command and then it will work. This is now needed, like you just execute it, this command, and then it should be fine, right? Like if you like with Kubeflow, when this is one important point, you know, when you use Kubeflow, you actually should know about Kubernetes. Like you should know about kube control. You should know about like how to apply this YAML file, like how YAML works there. Like I'm sorry, like I put this as a prerequisite, but once you use Kubeflow, you need at least someone. Like if you're a data scientist, if you're a machine learning engineer, and you have someone who knows Kubernetes, definitely grab this guy and or girl, of course, and then that they will show you okay how it works, because you definitely need, of course, some pre-knowledge there. So yeah, so like now let's go to the spinning up a new notebook instance. This is pretty easy and pretty straightforward. So we go to the notebooks instance. So I have already one, but like I will show you. So this is like, okay, let's say tests. You can check in, this is the namespace. It comes actually with predefined images. This will be downloaded from the AWS server. So you have here the PyTorch, CUDA-Full, TensorFlow, CUDA, whatever, SciPy, whatever you like. So because like in my example, I will use TensorFlow. That's why I pulled the TensorFlow Full. You can even like select the CPUs, 2.2 or 2.4, like with the memories there. If you have even GPUs, you can support it there. And now is the most important part, because we need to access the Kubeflow pipelines. So this is what we did with the YAML file. You have now here in the configuration like a tick, or like allow access to Kubeflow pipelines. And this is what you need to click. Because now you have actually, or this container does have now the privilege to talk to the Kubeflow pipeline, to the Kubeflow pipelines, basically SDK. Like the SDK is talking to the Kubeflow pipelines component in Kubeflow. And yeah, and then you launch it. So then it will go up. Like it takes some time, of course, in order to launch it. But you can see here, hey, everything is running smoothly. Yeah, cool. Like, all right, like with that being said, you can now like, oh, it's done already. No, this was fast. Yeah, I pulled already the image there, which is local cache. So once this is done, once this is pulled, the cool thing what you can do is basically you just connect here. Like you click on connect, and it will open a Jupyter Lab instance. So here we have a Jupyter Lab instance where maybe you're familiar with it. You can create a new notebook there, which is like here. This is, for example, we can hello world. Like you can print here the Python code. So if you click on Shift and Enter, it will execute hello world. Like this, it will execute. This is interactive Python basically. You can also say, hey, this is a markdown one, and then say hi, or like this is a caption, a heading. This works also. What you can also do is the following: you can open a terminal, so you can directly have here the terminal. And one very important part here is as well, and this is coming in the next docs as well, is you need to check with Kubeflow, especially in this instance. Hey, with piplist, are my Python libraries or my packages, are they up to date? Why am I saying this? Because it happens like in 1.5 at least that you have like not the latest Python packages there. So here with KFP and pipeline server, like I had 1.6, but you need at least for the new pipelines 1.8. And then Ksurf as well, like this is 1.8 Python packages there, so you need to definitely update them. So how do you do this? You just like say pip install and then put in here Ksurf or like all the others, the other stuff as well. So this is like Python 101 there. And this is as well, like if you scroll down, I had it here, like update the Python packages, so these should be listed here. Then, like access the Jupyter Notebook. So like what you can do, so I put them here, if I scroll up here again, these are the latest, these are the items already. So these are the final IPython notebooks there, which work. I tested them. So you have here the digit recognizer notebook and the pipeline there. So what is the difference? I will open it for you. So you have here the following. So we go to Jupyter Lab. I go here to the notebook. So the notebook is like the data exploratory mode. So here right now, imagine you're the data scientist or there's a data scientist there and you explore basically data. So we are importing here NumPy, Pandas, TensorFlow, like all the Python packages there. And then like that's the cool thing, or maybe I did it in an easy one, but it's already there, you know. So there is actually Keras, the Python library has already a function or a method where you can basically say, hey, load the mnist dataset. So basically, everything is nicely already put into train or like separated into train and test dataset with nicely xtrain, ytrain and xtest and ytest. And yeah, I mean, basically, it's a cool thing, you know, because you get the data there. Of course, you can pull it from an existing dataset there. You can pull it like you can do more data exploration. But for now, I just said this is the most important part is the Kubeflow component or the Kubeflow process. This is why I said, okay, let's leave it like this. So then exploring the data. So this is like really classic data science work where you say, hey, I explore the data. What is the shape of the data? So we have like 60,000 examples in the train set and 10,000 examples in the test set. The images you can see here is 28 times 28 pixels. And if we are actually seeing it here with the visualization, so we just visualize it, you can see it, hey, this is 28 pixels, like from 0 to 27. And here, hey, correct number is 5. Like here, you can see it's like, this is the correct number with the correct number 5. Then there is also like what you need to do then, of course, like to build the model and everything to the data preparing. So what we do here now is basically we say, hey, we are actually removing like with 28, 21, we are using just the kernel 1. So we are reshaping it. We are reshaping it with grayscale, so we don't need any colors or anything if there was there. And yeah, we can do this everything like with the Keras API. Then to normalize the data, so I won't go super into this one, but like to normalize the data to say like we know the data is 0 to 255 as a value. So basically the how gray it is and how here you can see like with the 5, like some are super black, some are white, some are grayish. So this is the value of each pixel. And of course, this is maybe too large for processing. the machine learning model. And so we want to trim down the data, we want to trim down the values there. And so we just divide all the values, we divide by 255. So we get actually values from like 0 to 1. So this is, we basically scale down the data, and this is mostly because it's better, or like it's faster to create that and to train the model there. So now we have this shape here. So we have 60,000 in the training set with 28, 28 and 1, and also the X shape is 10,000 with 28, 28, 1. This looks good from this perspective, like we did it. And now we actually can go to the model building. And like I said, if you want to do like a more deep dive on this model, so I just go over this very kind of quickly. Like there are tons of other videos out there which are explaining this in more detail. So for the model building, I just put a simple sequential layer there. So with this input shape 28, 28, 1. Just ReLU activation, then I do some max pool, then these. It's like I did it 3 times, then I flatten it, and then I put the dense layer there. And then you can do it whatever you like, and you can of course like trim it or like make it in more detail however you like. But more importantly is like the last part is that there is actually that you have like a dense layer like with 10 options, or like with the output of 10, which means like from 0 to 9. So we know what number it is. Activation softmax, so you can see, okay, what is you have like a multiple number of outputs there. And these are like the 10 classes there. And this is the model summary. So pretty straightforward what Keras is usually doing, like this model summary there. And then we compile the model with classic, like in the end, it's like I put nothing special in there. And with loss sparse category cross entropy. This is still wrong. We want to have a binary outcome. No, we want to have basically a categorical outcome. So I will change this. And then we fit the model. So like we say, hey, like let's train the model. You can change the epochs time, of course, there as well. So I just put now 1 epoch time, still get an accuracy of 93%. But with this data set and so on, I think it's definitely good and fine. All right. So with that being said, so like there is also model evaluation. So like model is built, pre-trained model is there. And now what do we do? So here now we save the models. We save the models to models detect digits in this folder there. This is like simple save model function there. So we don't save it in a file. So we save it in a folder. This is also important to know. Like this is the newer version, or like a newer option on how you can save the TensorFlow model there. And then this will come later on, because this is already involves min.io. So here you can, this is like just here for testing as well. You can basically save this model to your min.io instance. So min.io is a block storage, like a block storage solution running already, like it was already installed and comes with Kubeflow. So this is why I already used it. It's uploading it. So here, like this is the like you can also import or like export the model in the H5 format. Like this is the file format. But why don't we do this here with H5? Because when you go to Kserve and Kserve, the inference server, it does not support the H5 inference options there. So like it needs actually the output of save model, and it save model to a folder. So it needs actually this newer option or new version on how you save the model. And this H5 is basically the old one. Finally, like we test it, we evaluate here and see, hey, and create out of it the confusion matrix to see. Accuracy is 97. So it's this, I think this is also from another test site, this output here. But yeah, but you will run it anyways on your server. And yeah, this is the predicted outcome, so it looks pretty neat, I would say. So with that, it's like we have some sorts like here, like the 0 and the 6, like some of them are not that good, or not that good recognized, but all in all, I think we have a decent good amount, or like a good amount of accuracy here. All right, so just a like overview, okay, that like we did this. So if you're not that familiar with deep learning here, in a way we explore the data, we do some preparing, some splitting, we do some model building there. Then we do some evaluation to see like, okay, how is our model performing there, and also saving the model to like our data format of our choice there, or what the framework in our case TensorFlow is giving us. Yeah, so like with that being said, I think this is good. I will just go over now to the other part, which is now here. We access now the Jupyter notebooks. You can clone it. This would be also one thing. So if you don't know how to basically get the data, so you can just clone this, and like I had it already in here, but you can simply like git clone directly into the container. Directly can copy all the files there, so you have the IPython notebooks there in here. Cool. So let's go to our next step, and this is set up the min.io for object storage. So I will go up more again, right? So imagine this. You have the Jupyter notebook. You work with it. You have some output there and so on. And you need to store somewhere. Like the model, for example, what we created. Like you need to store it somewhere. And a classic example, I know a good choice is definitely min.io, where you have like object storage there. And you can also, and this is why min.io is also good, you need to, with Kubeflow pipeline, so we didn't create the pipeline yet, this was just the notebook code, you need basically also here access to min.io storage, because you can't access the Jupyter notebook there from Kubeflow pipelines. So you need to have some single source of truth there. And this is why min.io comes into play. So that's the cool part is that there is already a min.io tenant in Kubeflow. So basically, like, why is it like this? It's like they use it already internally, and you can already use it. You can for sure like take your own like I said, like min.io, you can set up your own, but I want to make it, as smooth as possible. So like I didn't do it. So yeah, like I used this is why I used basically the internal one. So how to obtain the access key and secret key for min.io? So first of all, like you can see that there is already in Kubeflow, like in the namespace Kubeflow, there is a service with min.io service on port 9000. So again, I go to my iTerm, open a new tab, I forward it to the 9000. So if I go to localhost again and I go to 9000, I actually go to min.io. So this is actually the min.io from Kubeflow. And what do I do here? I actually need to get the access key and secret key from there. And this is here with these commands. So when you run this, again, another iTerm tab, you run it and you can see here, hey, this is min.io. And then the secret key for that, let's check this one out, is min.io 123. So this is basically min.io and min.io 123. So min.io 123, I saved it already. And there you go, there you have it, right? So you have here, and maybe this is like from my testing, but this is basically, hey, you have the ML pipeline bucket there. You can create a new path. You can create like maybe in other instances there, depending on where you are right now. But like you see, like you have like all this storage there available. And what you basically see here as well, like these are the default values. So we are using now here min.io as access key, secret key, and the ML pipeline to see here all the models, or save basically our stuff there. Cool. Like that was it basically. Like we will later on use it for the Kubeflow pipelines, but just to know, like just to set it up, all right, we need to have some storage option there available. All right, like now let's go to Ksurf already. Actually, like we are going in the last sets of to the pipeline, but this is now something to do with Ksurf. So the thing is that Ksurf. So I will just check it out in Kubeflow here. So Ksurf is about model serving, like model inference. So to set up a server and to have it. So the Ksurf was previously KFserve, like named KFserve, and was part of one of the core Kubeflow components. So it was basically listed here. However, they now was moved to an external project there, and now Ksurf is an external add-on to Kubeflow. And right now, like in Kubeflow 1.5, you have like a bit of KF serving and Ksurf now. But I think in 1.6 they made it everything clear. Okay, this is Ksurf now, and yeah, so like basically it's this one where you say you have your cluster, you have your Kubernetes. Then they are using Knative and Istio, so this is also important to know. Okay, Knative is comes from Ksurf, and here basically you can do model monitor, like deploy your model, your machine learning model, the trained model. You can deploy to an instance, and then you have actually like an interface or an API where you can query it and say, hey, please predict this one. You send like via a JSON object, and then you bring it back, for example, and you bring back, or you get as a response, you get what kind of digit it is. Yeah, so like with that being said, this is you can see everything here. Like usually this you can see it in the documentation. And Ksurf also has now an own website, so there's also this is also really good there. So I think this one. So you can see here, for example, that this is all the website there. So administrator guy, you can see how to install it, basically everything. And then if you go to user guy and to here, like you can see like here, how does Ksurf do it? There's also like a transformer service, like if you need to have something transformed before it's going to the predictor service. I won't go into that, so we just use the predictor service. But what I want to show you is here like single modem service, and then you can see here like TensorFlow. Like we will definitely use TensorFlow here to basically create the inference service there. And yeah, so like inference service, I will come to this also in a bit. So we need or like what you see here is basically you are creating with YAML, like with Kubernetes and with a Kubernetes YAML file. You are creating here an inference service, like kind inference service, using Ksurf. Then with the metadata, you say, hey, I will name this like this is the digit recognize example. And then as a predictor, you use TensorFlow, and the storage URI is this one. So basically, you need to put in here the storage, and we will put our object storage, like our min.io instance there, where you have basically the like the flower, like here the models there. Like in this case, it's the flowers, but in our case, it will be the digit recognizer there. But we won't use this. I mean, we can use it, of course. Like I also put this in on the GitHub, but you can also do this with Python, with the Python SDK, with the case of Python SDK to create some inference service. Cool. But let's actually now, like this was Ksurf now, like it's just an overview there. And the thing is that now we need to set up Ksurf again. So what is it about this? So we need to apply here, again, this is Kubernetes related. We need to give the min.io secret to Ksurf. So actually that Ksurf knows about, hey, okay, I can access the min.io, the object storage there. So basically you can see it here, like Ksurf will copy the saved model into the newly created inference container, and we need to allow this. So if we go now to Kubeflow configs and set min.io secret YAML, so this is again also in here. So Kubeflow config, set min.io secret. So here again, you need to check. So the namespace, Kubeflow user example.com, is it the same, your namespace? You need to check it. The name can stay the same. Then I would, it's written here S3 endpoints because it's compatible with min.io. So this is why I put here S3. So this is the min.io service Kubeflow on port 9000. We are not using HTTPS and any credentials. And here is the access key and ID, so what we use for getting into min.io. And then, this is one part of the YAML file. So this is the secret what we create. And then here we are actually creating a service account. So in this service account, again, in the namespace kubeflowuserexample.com here, same namespace, we are adding this secret min.io kserv secret for basically that our what we are creating, with kubeflowexample.com, or the inference service what we are creating, that it can actually access the min.io, the min.io instance there. All right, so once we done this, like I said, so again, I'm going back here and going down to setting up kserv. So basically, again, you just copy paste this here. So I won't do it now, I did it already, but you can just copy paste it, Kubeflow apply, and then it should be applied. It doesn't do anything, it just said, okay, created or successfully, so that's good. And so if you run into any troubleshooting issues, there are on the website, you can find here good documentation there. So usually what I needed to do is basically, I couldn't fetch a Docker image. So I needed to do some do something in the configuration and put the registry scripting tag resolving in index docker.io. I need to put it from here from the example directly under the data one. So I needed to basically do it here, and you just need to copy paste this command. And then work in Vim basically, or in any editor of your choice, and then move it under the data one. But everything should be written here, so maybe you don't have any problems there. All right, so with that being said, we are going now to the major part, and this is to create a machine learning pipeline with Kubeflow pipelines. So Kubeflow pipelines is the most used component of Kubeflow. So it's this is why lots of people are basically using it, and it allows you to create for every step or function in your specific machine learning project a reusable containerized pipeline component, and which can be changed together as a machine learning pipeline. And this is the cool part, because you basically have it already there. So this is in the digit recognizer pipeline IPython notebook, and we will go over this right now. If you're unsure about different things, because the documentation I unfortunately have to say is not the best, you definitely need to figure out a lot but a bit learning by doing, a bit on the documentation side of Kubeflow, and I think they have again moved it or so. Okay, there was in let me just, maybe it's a wrong link here. Yeah. So here, this is the link. I will definitely change this. So here is I would say also pretty good documentation where you can see, okay, how do you do the functions? How do you create the functions? How do you deal with Kubeflow pipelines? And how everything works, because I think this is very important for you to know. For me, it was a bit, I would say, tricky because of the documentation, but this tutorial helped me, and I hope my IPython notebook pipeline instance will help you as well, of course. Now let's go to Jupyter Lab, and now basically let's open the digit recognizer pipeline. So what do we have here? So I will go through with this with you. So in the end, what we have here is like we are importing the KFP, so the Kubeflow pipelines Python library there. And then we have actually a number of functions. So here is like, for now, it's fine that we're like inserting this, but just be with me. You have the definition get data batch. You have the definition or like the def or the function here get the latest data. Def reshape the data. Then def modeling with some outputs or like some inputs there. Sorry with that, but like okay. And then we have here like this goes down, down, down. Model serving. This is like for model serving, and then and here we stop, right? Like here in the end, we kind of say okay, we stop here right now, and this is all the functions there. The functions of and you can see it like this that every function what I defined there is one component, and this function is running in its own container, which will be created. And now comes the next part. The next part is these things. We are actually defining or like creating the container with these definitions here. So we have here the component get batch data. We say here from, and this is the KFP. So if you're saying like components is part of the KFP Python library, we create a component from this function. So we are creating a component from a Python script or from a Python function. And then we say this function like get batch data from up there. Please, this is the function what we want to create the component from. And then this is the base image. And I just used to be honest, I just used the same base image there, what is already in there. So the same base image what we have there. You can use others like your own, of course, whatever there is. So if you plan like to have a really cool machine learning pipeline there, you can create your own container image, what fits your need basically. And we do this for every function here. So we say create a component from function, get latest data, reshape data, model building, model serving. We're using the same base image. And just with the model serving, like kserve wasn't available. Like kserve is not per default in this component, in this how is it called? In this container, in this Docker image or in this container image. And that's why there is a really cool function, and everything is written in docs. What kind of packages should be installed there? And then I said, hey, please install because we need it in the kserve Python SDK. We need this one, so please install it before running this container image or before starting the container. This is again create component from function. This is just an option. So you can create a component from a function. You can create a component from a YAML file. You can create a component from a different with a different just with a base image, setting up or running a base image where your code is already in there. So there are lots of other options on how you can create your component. I just used a very simple one to say, hey, this is one in this component model serving. Just run this code here, and then create this kserve instance. So I will come to this later, but this is one component there. But that's not all. So that's not all. One thing is important there is that there is as well basically a definition or where you need to run or define the whole pipeline. Like now we define the components, but how can you define what component should come after what? Like how does the step look like? And how does the pipeline look like? Which component should run first, which one second, which one in parallel, and so on. And this is here, we are actually defining our pipeline. So we define name digit recognizer pipeline. We say detect digits. And here is now the following, the output there, or like the test, the output, which is now we say, hey, step 1 and 1, like this is in parallel, I said, is like the get the data batch and get the latest data should be in parallel. Then the step 2, which comes after step 1 and 2, this is this component reshape data. So basically here we are. So we are saying, hey, we have the component reshape data. Then comes the step 3, which comes after the step 2, which is component model building. And here we actually are giving some options there for the machine learning pipeline, like for the in the Kubeflow like UI, and you will see it like in a bit. That you can define here the number of epochs and the optimizer, so that you can choose it, and which will be executed with it. And then step 4, which comes after step 3, is the component model serving. So this is where we create our K-serve instance. And yeah, so this is it. Like of course, like I put some like here to just to say it here, like what I did here is. You have here the client, like you connect the Kubeflow pipeline client there. These are the arguments, the default arguments, like number of epochs 1, optimizer is Adam. And then I just put it here if we want to run it directly, which means that I want to run it with create run. So per se, I create the specific pipeline. I want to run it immediately. With the experiment name test with this on these arguments. Or for example, I can just compile it like to a YAML file. Like I can put the whole pipeline in the YAML file there and then basically do a upload pipeline version. So basically I say with this YAML file, I upload it with this pipeline version name, with the pipeline test, with the description class testing. So this is in the end, it really depends on what you want to do, because like I will go back to the dashboard. So how it's usually done is that you have here, and these are these three things here. You have experiments. You can basically create an experiment, which means that this is one machine learning experiment when it comes to the recognizing the digits and so on. So you can create it here. And you can see here, like this is the test experience name. So you can see here the outputs there, like was it the status, was there a failure, the duration here, and so on. Like this is basically about the experiment there, and I will come to this in a bit as well. Then you have the pipelines. So these are where basically your pipelines are being stored. So if I would do the second choice, like here would be the pipelines there. And finally, these are the runs. So these are all the runs which are executed. And of course, you can archive ones and so on. But basically, these are all the runs depending on which pipeline there as well. Cool. Like yeah, with that being said, we can like execute this one. So if we execute this one, you will just see experiment details, run details, so that it runs. So if I execute this here now, everything, experiment details, run details will be fine. And now let's actually check what's happening. So if I go to runs again, let me just redo it. You can see the status, so it's running. Everything is good, so runtime is there. And if I go to the experiments, even I think like you can see here as well that everything is good. And now the cool thing is the following. You can see here that these are the outputs of model accuracy and model loss. You can see here like in the specific parameters there. You can see the start time, the end time, and then more importantly, and let me go to a really nice pipeline there, which worked, is you can see here all like how the pipeline looks like, and then as well like click on the graphs and then see basically the input output and all the information on the specific component. So for example, like get the latest data, you can see here we are adding the latest data, and with latest data, if we are going to the Python to the Jupyter Lab, we can see here that get batch data, get the latest data. This is okay. This is just adding latest data, this is a dummy function for showcasing. I wanted to showcase, that everything is in parallel. Then let's, however, go to get batch data. And you can see here that we are actually saving, and let's go first to the code. So here is basically we get the latest data. So we get the data set. And what do we do here? We are saying data points training, data points test, data version. We want to have, and this is like part of the Python, how is it called? Like the Python library. So you need to define this. You need to define this here as a name tuple. This is what's written in the documentary. This is how you need to define it with the outputs there. And here we run this. This is why we need to import it again from here. We need to run this, or this code will be run in the container. So this is why we can't import everything on the top. So we are actually importing this one, or this code will be run in the container. And this is why we need to import it from here. So we import TensorFlow and everything. We are connecting to our MinIO client. So here, this is the IP address of the MinIO client. And then we're saying, hey, get this MinIO client fget object. So we are actually saying, hey, I would like to get the MNIST data set from MinIO and save it temporarily here. You can, of course, download it directly as we did with as I did in the Digit Recognizer notebook. However, for versions to keep up and so on, I thought it might be good as well to keep it basically in a MinIO bucket there. Then in the end, you save it. You save all the Xtrain, Ytrain, Xtest, Ytest, and so on NumPy files there. You basically say, hey, this is the dataset version. You can define it here. You print this the X and the shape there, just for to see. And then this is the output collection with the name tuple. So what we do is, in the end, we are saving everything from to MinIO. So when we go there, you can see here that we are saying the data points test is like 10,000, data points training 60,000. This is the dataset version, what we defined. And these are the logs. These are the logs that we say, hey, okay, we deleted it. We are actually getting the data. This is the shape, and this is fine. Like, you can ignore this this error here. There are some details, if there are some logs there maybe, then events, machine learning data, and so on. I don't know why there are no logs. Okay, let's see. Anyways, so then we are going to reshape the data. So we are going to say, hey, this is reshape the data. So if we go to the logs here, we again getting everything from MinIO. So we are loading the test and the train data, and then we say, hey, we would like to reshape it. So we would like to reshape the data what we did before in the notebook, IPython notebook. So in the Digit Recognizer notebook, I have to say. And then we save it back to MinIO. So this is all what it does, all what this step does. So basically reshaping the data, looks good, the details is there and so on, it should be fine. And the next step is model building. So basically here you have the input parameters, and if you actually want to run this here like in your own with your own pipeline, you can actually input these parameters directly in here. So it should be here in the config that these are the run parameters, and you can actually, if you want to run it directly in the dashboard, you can also configure the input parameters there. So number of epochs is 1, optimizes Adam. And let's see what the output is. So the output is following. So like we have here the UI metadata and the metrics. So the metadata and the metrics. So you have here model accuracy and so on. Like these are the things what you actually see them in the experiment step. So when we go here in the experiment step, you see the model accuracy, model loss. This is why actually these are the parameters which can be seen there. So if I go back to the run, let's see this one here, model building. And then yeah, you see like there's this number of epoch is 1, like maybe I should have put 3 or so. But yeah, you can see, okay, the accuracy and everything and how it is. But then again, it also offers visualization. So you have here already like a confusion matrix, and you can put here different visualizations there. I have to say it was pretty tricky to basically put this confusion matrix together in a way, because like the documentation and so on is not the best, or wasn't the best, especially when it comes to these are the outputs, this is the confusion matrix, this is like category and so on, with predicted and with target and so on. So it was kind of tricky to read through documentation, also depending on to see okay how it actually works. Like there are some examples, like I have here put the confusion matrix there, which worked, and then I also put here the markdown, which means like I also put in here the markdown files, like you can see here, like the model summary, the model performance, and accuracy and the loss basically. And yeah, so this is all, like usually you have here the logs, usually there should be the logs there. And then yeah, machine learning metadata is a different story. However, I didn't go into this one there, but you can put visualizations there and specific summaries in here, which is actually pretty cool, I would say. How does it look like in the code? So in the code, it's not that different. So you can see here that these are the input parameters, also of course with the name tuple there. And then again, you have here like a connect to min.io client, and then I actually do everything. I create the sequential model, show the model summary, how it looks in a way. Then I compile the model there. So basically, hey, compile it. And then, yeah, we need to get some data, of course, for the model fit. And then we are actually saving this model we at first we get the X test and the Y test, of course, and then we evaluate, okay, how it's done and so on. Then we predict it, and this is also the code, like how to generate the confusion matrix there. And this is basically the metadata. So this is like the model summary of what you see. So like I did the format, like I said, okay, how much is like the metric model, metric model summary, model accuracy and loss. So like I put this here, and this is basically the metadata. This is everything Kubeflow pipelines related, in order that it's visible basically here in the visualization. And then finally, now what I wanted to say is, like, now we actually, like, after this, we save now the model from the temp folder to the detect digits. And again, this was already in the other code as well. So we are adding it and uploading it to min.io. And there is one very important part which took me some time to realize, is that like the TensorFlow model inference, what Ksurf is using, the inference server, they need to have like this version number. So models, detect digits, and this is like /1, like in folder 1, like this is 1 for version 1. It needs to be versionized. And this is why it's very important, like, to put here the 1, so that it actually, if you go to min.io browser, and I think, no, it wasn't pipelines, it was in models, detect digits. So it's very important, like this is like from an old tryout, like you need to have the 1 there, so it actually gets to the 1, and you need to point you need to have the 1 there in order for the inference server to take it. Otherwise it says you will get the error, hey, you didn't versionize it, or there is no version available for this pre-trained machine learning model there. Yeah, all right, like in the end, this is it. So you see, this is kind of like the whole code. So at first we do very similar to in the other notebook. We do the compiling of the model. We get all the data from min.io bucket there. We do some evaluation. We do the predict with the test data set. And then, yeah, we do some in a way, I would say, like with this one, we create the confusion matrix there. It's still, I think, the other way around and so on, but like confusion matrix, it's still like in a way, like I think the documentation needs to be a bit better there, but all in all, like you can create something like that in the confusion matrix there. All right, like I think this was basically it, and then yeah, finally, like I said, yeah, you save this into the min.io buckets with, and you need to versionize it. Yeah, once done, we are going to model serving. So we are creating the Kserve instance. So what's about this one here? So when you go down, we are actually again, we need to install the Kserve package in the container, and then we are creating here the imports. Then we say here, okay, get the default target namespace and so on. Like this is from the Kubernetes client there. And then we are creating an inference service there. So basically, with this Python, Python library, we are actually creating this specific inference service there. And here you can see the URL, like the URL or URI where you can see, okay, where is the model located? And the model is located with S3, so like this is compatible with like the S3 storage, what you have in AWS is compatible with min.io in this module there. And this is like min ML pipeline model citate digits. Don't put the 1 in there. Like here, it's fine not to versionize it. And then now here it will grab the latest version there. And then, yeah, you say, hey, I would like to create this service, connect to the client, of course, and then create this service there. What I also did for you to try it, if everything works, because it can be tricky with this one here, with Kserve, I also put in here, and you go to the Kubeflow configs there, that you create a Kserve instance here. So basically you have here the YAML file for the inference service. So what you can do theoretically, or like practically as well, you can copy paste it here. And if you go to models, and this is basically all the models, all the model servers, what you have there. And when you create a new model server, you just copy and paste it here. And then you can create a model server there, which means you create it in a Kubeflow example. There is something with Istio. So it's like the thing is that you need to have like with Kserve, or like Kserve is using Knative and Istio, and I did everything like from like scratch and everything like as fast as possible, and that's why in order to get access to the inference service from the inside of your cluster, like you know that you can run it, I actually did the inject force. So that it's basically, accessible from inside the cluster. From outside the cluster, it's also a different story. So you definitely need to check, okay, what is your, like, how does your cluster look like? What is your URL and so on? How is your lab environment? So it's for now, I think it's kind of tricky to access the inference service from the outside, especially when you have like just a quick and dirty demo. But you can for sure set this up in the lab, and I think they even are working on specific to have like a non super secure stuff available. And yeah, where was it? The specs, the predictor. So you have here now the account name SI min.io Kserve, like that you are actually have access to the min.io instance there, like that Kserve has the min.io instance, and this is the storage URI which the model service is accessing. All right, so the other one is not there yet. So yeah, the service may be a bit slow here. So I will just go to digit recognizer, like to the which is already there, and you can see here. This is like the external UI, this is the internal UI. So again, it really depends on your setting, how you can access it. And this is actually like also very interesting, or like that you are actually here. This is the API, or like basically the URL service where you need to send the post to from the REST post, basically post command there. So you have version 1, you have the model digit recognize and predict what you sent there. And it is actually up, right? So like you can see here CPU limits, like everything, like TensorFlow is the predictor. There are some logs, like it's actually up right now. Like this is the YAML file for this, but digit recognize up and running. So if you send anything for prediction to here, it actually should work. And so there are two options now, and I'm coming here now to the last part already, to the 7th part, which is test the model inference. So you can test the model inference. So either there are two options now. The simplest way is, of course, like use the Python script. This is directly inside of the here in the GitHub folder, or you can also do it with the web app. So I created here, and you see it up there, like a simple digit recognizer web application where you draw with your mouse, and you have this web application actually here in there. So I just used here like a simple, index HTML. So I just used here a simple canvas and then some JavaScript code, where basically I say, okay, the user can draw the mouse, then I will, with the TensorFlow JavaScript library, I will reshape, or like this tensor, like this image there, this canvas there, sorry, to 28.1, as we have with the input there. And then I send it basically to the predict, to the local host, or like wherever you have with fetch, and then you get the example output. And here again, like I said, so definitely feel free here to define whatever you like, basically. So like here, like I said, output still needs to be formatted. So basically, usually you have here the log will basically say, hey, this is the data, but I didn't put any specific output there. So this is really up to you how you would like to see the data there from the web application, of course. With that being said, let's actually go to the more like easier way or faster way as well. Here again to Jupyter Lab. So there is one Kserve Python test, IPython notebook. So you have here, I actually import here like the Kserve and everything. The actual number of this array basically is 5. So you can see here, this is not the scale down. So you see here it's like from 0 to 255, the number. So I just took the random number. So you see here like with the 5 here, I just say, hey, print me out the number. I just print me out the number there, and then put it into an array. Basically I say, hey, with the Kserve client, I say, hey, give me this, give me the inference service. Definitely give me the address, the URL. Then create and reshape the tensor there. And then you need to do basically with the inference input, it needs to be in a list. So I basically put the tensor, and then because you need to send it, and this is also a bit tricky, of course, how you send it to the service, but you need to put here instances and then the tensor to the list. To put on the tensor on the reshaped tensor, you need to apply like to list the method, and finally you can actually like request it, and you can see here, hey, okay, I get the response back, and then you can see here with Argmax the predictions there. So if we run this now, actually it works. So you have here the number 5, and the predicted is the 5. Is the 5 there. What I maybe want to show you is like what you see here is that I already put on predictions the Argmax format. So like let me show you this one. So you are actually receiving back this one here. which means that this is what we defined. So in the softmax, we have the output of 10 options, or 10 cases, like from 0 to 9. And you can see here, like, what is the argument, or what is the number, the accuracy for, is this number a 0, 0, 0? Is this number a 1? No. 2, 3, 4, 5, and here on the fifth element, there is actually the predicted number, and this is why what this argmax does, it actually says, okay, where is, in which order, or in what order is the largest, or the maximum number there of all of it. And then you can see here, okay, it's definitely, because everything is 0, 0, this is the largest number, and this is on the fifth position, in the which position there, and this is then, it is predicted as 5. All right, so yeah, like I said, you can also try with the web application, but for now, I think with the Python, I think we actually said that it works, and this is it. So I hope you enjoyed it. So I hope you could see, okay, like how everything works. You can see here, like how Kubeflow works, how the pipelines are working, and of course the models there. And yeah, I hope you enjoyed it. And yeah, wish you all the best. See you soon. Bye bye.